this video is on converting decimal fractions to binary. So I'm going to go from a decimal number here that is 59.5963. I want to convert that to a binary representation. So I'm going to take this whole part here, the 59, that's the whole part. So then 59 divided by 2, so that is 29. And there is a remainder of 1. So let me write my answers here. So I'm going to put my 1 there. Then I'm going to take 29. And if I divide it by 2, so that's 14. So 14 divided by 29 divided by 2 is 14, remainder 1. Now 14 divided by 2, it is 7, remainder 0. 7 divided by 2, it's 3, remainder 1. See, I'm going right to left. Now 3 divided by 2, it's going to be 1, remainder 1. And therefore 1 divided by 2, which is 0, remainder 1. That's it. So this number here is actually this binary digit here in decimal is 59. Let's check it out. So this is 2 to the 0, 1. That's a 2. That's 8. 8. This is 16, 32, and 6. Wait a second. This is 2. That's 4, 8. This is 8. Okay, this is 8, 16, 32. So this becomes 40, 56, 7, 8, 9. So this is correct. So I can confirm, I can verify. Now, how do I convert the decimal part? 0.5963. So the way I'm going to do that, so it's 0.5963. So some of these may never terminate. So I'm going to take 59.63 multiplied by 2. So that's a 6, that's a 2, and this is, that's a 9, okay, and that's 1.1. So take this one here, goes right there. Then take 0.1926 times 2. So that's a 2, that's a 5, and this is 8, and that's a 3. So it is 0.3852, correct? So that's a 5. Okay, that's correct. So then I'm going to take 3852 times 2, and that gives me 4, that's a 0. That's a 7, and that's a 7. See, another 0 there. Okay, so that's a 4, 0. Okay, so this is 17, and that's a 7. Then continue. 7704 times 2 is going to be 80451. So that's a 1 there. Okay, so we still continue. 0.5408 times 2, so that's going to be 16. That's 8 and 0, 1. So I'm going to stop right here at 5 places of precision. So that should do it. Okay, if you look at this, this is 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th. We go down here, that's a 1 plus 2 plus 8, 16, 32. So this becomes 40, 56, so that's 59. Now this side here is point -1, -2, -3, -4, -5. So how do we do this? So this is going to be 0.5 plus 2 to the, so 2 to the fourth, so that's, okay. So that's 1 over 16. So if I take this, 1 divided 1 over 16, so that gives me, this number here is 0.0625 plus. Now, 2 to the negative 5 is 1 over 32. So that would be 1 over 32. So that gives me, this number here gives me 0.031203125. Okay, so let's see how this comes up. So I'm going to erase this, how we solve this problem here. If you look back here, this comes out to be 59. Now this number here, it's 0.5, add this one 0.625, and this one is 0.3125. If I add this, I get a 5, I get a 7.395. See, so that gives me 59373. So the deeper I go, the more precision. If I have 5 digits, 6 decimal precision, the more accurate the number is. So I get 59.59373, which is very close, and I just made it up to 5 decimal precisions. So this is, I can do another example. So for instance, let's make a smaller one. Okay, so here's another example. For instance, I want to convert 17.9321. I want to convert this to binary. So again, that's in my decimal place, that's the whole number, and that's the fraction. If I take 17 divided by 2, this is 8, remainder 1. So here, put my decimal, put my 1 there. See, I'm going right to left, so this 1 is there. Then take 8 divided by 2, which is 3. So 8 divided by 2, that's a 4, remainder 0. So there's a 0 there. Now take 4 divided by 2, which is going to be 2, remainder 0. Now how about 2 divided by 2, which is 1, remainder 0. Then I take 1 divided by 2, which is 0, remainder 1. So this number is 1001. That's my, that's 17. How about the next digits? So I'm going to go to 5 decimal precision. So I'm going to take 9321. I'm going to multiply it by 2. So this becomes 2, 4, 6, 8. So see, so that's 1.8686. So that's a 2, 4, 6. Okay, so take this one, goes right here. So on the decimal part it goes this way, on the whole number it goes that. Now I'm going to take 8642 times 2. So this becomes 4, that's 8, that's a 2, and this is 1.7. So put the 1 here. Okay, 2, 4, okay. Alright, then take 0.7284 times 2, which is going to be 8, and that's a 6, that's a 5, 4, okay, so my 1 again. Then, again, I'm going to continue to 5 decimal positions. So this is 0.44568 times 2, this is 6, that's a 3, that's a 1, and this is 9. See that? I put my 0 there, so 6, 2, 1, okay, so that's correct. Then I take 9136 times 2, so that's going to give me 2728, so let's stop right there. So this is my binary representation. So let's see how we can evaluate this. Accordingly, the way we evaluate these, so I'm going to erase these parts so that I can show you the answers, the result. So the way to, so remember, this is the whole number, so that's 2 to the 0, 2 to the first, second, third, fourth. So 2 to the 0, so that's a 1. 2 to the first is 2, so 0, I'm not going to count it. Fourth, I'm not going to count that because that's 0 unit. 2 to the third is 8. 2 to the fourth is 16. So when you add these up, I get 17. Okay? Now, let's go through the other way. Now, for the second part, okay, for the second part here, this is 2 to the negative 1, 2 to the negative 2, negative 3, negative 4, negative 5. Now, accordingly, 2 to the negative 1, this is 0.5, okay, plus. Now, 2 to the negative 2, which is actually 1 over 4, just to make sure I'm not, okay, so this part here, it's 0.25. Now, 2 to the negative 3, that is 1 over 8. So if I got that one, so that gives me 0.125. Now plus 2 to the fourth is 1 over 16, so forget that. 2 to the fifth is 1 over 32, so that gives me 1 divided by 32, so that gives me 0.03125. So these are my decimal digits. So now I'm going to add these. So let me put them in this way. This is 0.25. Sorry, that's wrong. So this is 1, 2, 5, and this number here is 0.3125. If I end up adding this, I get 5, 2, 6, and this is 0. And this is going to be 6, 7, 8, so that's a 9. See that? So what am I ending up with? 0.90625. So this is my answer. So I get an approximation there. Let me see if this is correct. So 5, that's a 6, and this is 0. So I get 6, 7, 8, 9. So I end up with 17.9063. So that's basically how you convert a fractional decimal number into binary. So as you can see, the deeper we go, the more decimal precision, the more accurate the number becomes. Well, thank you for watching this video.